and today our lesson is on 5.2, the energy conversion. So basically we're converting energy from one form into another form. So here's some example. The energy can be converted from one form to another. So in here we call that energy conversion. Okay. Now, in here the first example, we use a toaster. When you switch on, it will transfer the energy from the electricity to the toast. In the second one, so in here the candle is burning. So in here the energy is being converted into light. So in our last lecture we have been talking about what was the chemical energy in the candle. Okay, so the next one, we have a plant and it's carrying out photosynthesis from the sun, and it will be collecting energy from the sun and is combined with carbon dioxide to generate starch, which is the energy for the plant, and giving out the byproduct, and a lot of you know what that is oxygen. Okay, so oxygen is actually a byproduct of photosynthesis. Now in here, the next experiment, we have some simple energy conversion. So let's watch the video first. Okay, so in here, let's take a look.
Push a trolley against a spring and then release it. What is the energy conversion? Rub your hands quickly about 20 times. How do your hands feel? When you are rubbing your hands, do you hear any sound? What is the energy conversion? Place the solar-powered fan in sunlight. What is the energy conversion? Release a ping pong ball from 30 centimeters above the bench. What is the energy conversion when the ball is falling? What is the energy conversion when the ball is rising after the rebound? Your teacher will connect an LED to a lemon cell. What happens to the LED? What is the energy conversion? Your teacher will connect a circuit as shown. Observe carefully when the switch is closed. What happens to the buzzer? What is the energy conversion? Your teacher will hold a metal spiral above a candle flame. What happens to the metal spiral? What is the energy conversion? Your teacher will burn a magnesium ribbon in a Bunsen flame. What is the energy conversion?
Okay, and let's go back to the first part of the experiment here. So in here there are different stations, and the first one is the spring, and we're looking at the Charlie. So in here, what is being stored in the spring? And someone should know that is the potential energy, because you compress the spring, you're putting more and more energy into the spring, and when you release it, the trolley will move. So when you see something move, it's kinetic. Okay, so that's the first one. Now in the second experiment, that is the one you're rubbing your hands 20 times. So when you're rubbing your hand 20 times, how do your hands feel? The first one is your hands should feel warm, because it's generating a lot of frictions between your hands. And do you hear any sounds? And yes, you should be able to hear the sound generated by the friction. Okay, and in here, if we summarize it, when you are moving your hands, what kind of energy is that? When in here, when something is moving, we always say it's kinetic energy. And when you can feel there's something between your hands, that is the thermal energy, the heat, because it feels warmer, right? And of course, you will hear the sound as well. So that is the sound energy. And in our station 3, we got a solar panel with the fan on it. So in here, we are observing something from the sun. What is that kind of energy? We call that the light energy. And the light energy from the sun is being converted into the fan blades. The blades are moving. So what is that? That is kinetic energy again. And the next experiment is the release of a ping pong ball. Okay, so in here, the ping pong ball is at the height of 30 centimeters, and that is the potential energy, because we raise it to 30 centimeters, then we release it. When you see the ball is bouncing, it's moving, right? So when it moves, it's converting the potential into kinetic energy. And also, what happens when the ball is rising after rebound? So it hits the floor and then it bounces up. Okay, so when at the moment it hits the ground, the kinetic energy is convert all of that, because it's moving. At the point, it just change all of it into potential energy. Okay, so it bounces up. So from the floor, bounce up, and then it will stop rising, and then it will just keep going back down. So the kinetic energy is converted back into potential energy. And in the next part, in here we got a lemon. It's connected with the metals, and one of them is the copper metal and the other one is nickel. You will learn that later on in Form 2 and Form 3. So when you connect those to a LED light, what will happen to the LED? It will light up, because there's some energy being generated. So what is the energy here? So let's take a look. So something is stored in the lemon cell. So in here, what would that be? The lemon actually would have the chemical energy. So in here, the lemon is acting as a battery. It's same as the one you buy from the stores, those batteries. Of course, the lemon wouldn't generate that much electricity, but it will generate enough electricity to light up the LED lights. So in here, it will light up the LED lights. And just on the side note, if you actually take a look at this, you can use other pens as well. In here, a potato can be used. And in India, they found a cell that use grape juice. So let's take a look at the potato one. Okay, so you see in the potato case, it's also converting the chemical energy into the light energy. So there are a lot of energy being stored in different kinds of plants as well. So in here, next part, number 6, we have a buzzer. And we got the conventional batteries, and when you switch it on, what will happen? It will produce a buzzing sound. And from that, what is happening? From the battery, we have the chemical energy being stored in the battery, and then when it go to the buzzer, it will generate the sound energy. That's why you can hear what is going on. And number 7, in here we got a metal strip being held up there, and underneath there is a candle. So what will happen to the metal? So in here, the metal, it will start to turn. So when it turns, it will start to move. And in here, the energy conversion. So the first part, the energy is being stored in the candle, is stored in terms of the chemical energy. So when you burn the candle, this chemical energy is being released. And what would happen to the metal? So it would turn into kinetic energy. So that's why you see it's starting from the chemical energy, change all the way into kinetic energy. In number 8 here is one of the experiments that Form 1 students should try. And in here, the magnesium ribbon, when you burn it underneath in the Bunsen burner, you will see there's a really bright light. You should not look directly on the burning magnesium because it releases such intense heat and light, and the light itself actually burns your eyes. So I know it's one experiment that is fun, and you have to be careful with what you're doing. So in here, what is happening? In number 1, what is being stored in the magnesium ribbon? Again, it's the chemical energy. And in here, when you're looking at that magnesium that is on fire, you will see that the light energy is being released. And yes, beware of that. Actually, it's extremely hot. That's why it mentions the thermal energy here as well. Please do not touch those stuff because it's extremely hot. And in here, that is the first part of the experiment. In here, the key point is the energy is being converted from one form to another. Now, in experiment 5.2 is a demonstration, and every year it's actually a fun demonstration to see how electricity is being generated. So in here, all I can do is show you a video first. So let's take a look at the video. So in here, let's take a look at the video.
Your teacher will set up the apparatus as shown. Add water to the boiler until it is about 3/4 full. Put some cotton wool in the fuel trough. Wet the cotton wool completely with alcohol. Light the alcohol in the fuel trough to heat the water in the boiler. What happens to the wheel? What happens to the light bulb? What is the energy conversion that takes place in each step of the process of generating electricity?
Okay, so let's take a look. So in here, in this experiment, we're looking at a setup like this. And actually, if you're looking at the steam engine, actually it is really similar to what they have come up with in the first steam engine back in the UK. And with that design, actually it jump-started the whole industrial revolution because of the steam engine. And I will show you some picture of what it looks like first. And actually the steam engine. So in here, without the steam engine, the first industrial revolution could not take place at all. So let's see if I can find a really old one for you. And actually you see that even those trains in UK, they were, well, actually that's how Thomas was designed. With that design is the steam engine. And let me see if I can find the steam engine. This picture. So you see that's some of the old designs of the steam engines, what it looks like. So with this kind of steam engine, actually it can generate a lot of power. And with that, it could push the train, and also it push a lot of wheels to move. And with that design, you see the first one, the old design in here. Actually, if you take a look at it, it's a really old design. And actually some of those still works in the old factories. And the design itself is really similar to what you have seen in your textbook. It has a boiler, and then basically it boils the water into steam, and it pushes the piston to work. So it will keep on moving, turning a wheel. And that's how we generate the power. So let's take a look at what we have in the textbook. So in here, after the wheel is turned, it will turn a generator, the step feed, and from that it will turn the light and it switch to electricity. and then it will switch on the light bulb. So in here, it will tell you the step of adding water. Okay, so what would happen to the wheel? It will start to rotate, it will start to turn, it will start to move. What happens to the light bulb? It lights up because there are electricity being generated. So let's take a look at the step one by one. So in here, let's take a look at the first step. We put the alcohol as the fuel to burn. So in here, the first step is, okay, I have to wait for it. Okay, so the first step, it is the chemical energy is being stored in the fuel. So in here, it will start to burn. Okay, so in here, what would happen next is it will turn it into the kinetic energy of the steam, because the steam was actually from water, right? So before it was boiled, it's just water. So we'll put more and more heat energy into it, and then it becomes steam. The steam will build up the pressure. So we have learned that in our last chapter. With the pressure, it will want to move somewhere. That's why it turns into kinetic energy. With that pushing force, with the pressure, it goes into the steam engine. So what will happen next is it will turn the wheel, which is giving you the kinetic energy. From that, with the turning of the wheel, there's a bell that connects the wheel to the generator. So what is being generated there? It generates electricity. So you see the word generator, it means that it will make something, it will generate something. So in here, in our case, is it will generate electricity. And from the light bulb, what will it give out? The light and thermal energy. So it will give out light and heat. So that is the whole process of how a generator works in generating electricity. So basically, more or less, even with today's design, is mostly like that without the steam part, but they will be burning something else instead. So in here is the idea of how it works for the chemical energy and turning into kinetic energy and then electricity. That's how we use it. Okay, so in here, the next part, in this experiment, I wouldn't expect you to try that. You can measure that at home, you can try to see it, but some of the apparatus, you'll need to have it at home. So I will just show you the video and some of the answer for this part.
Set up the apparatus as shown. Pull the weight down and let go of it. Record the distance the weight travels. Repeat the steps 2 to 3 times and take the average. Repeat the steps using different rubber bands.
Okay, so let's go back. Okay, so please record this reading because we don't have the equipment here to show you online how it can be done. So please record this as your reading first. because we'll need to go back to the textbook and fill in the blanks. So in here, we're comparing two different rubber band and how it's going to stretch it and what distance. Okay. So in this one, the first one is the hypothesis, what we're trying to find out. So we want to find out a wider rubber band stores more potential energy than a narrower rubber band when stretched. We want to see if it actually works like that. And then what material is needed? We need the different rubber bands, the stand and clamp, the weights, tapes, and the measuring ruler, the meter ruler. And in here, as you have seen before, and you have seen in your exam already, in your half-year exam, and you should be able to tell me what are those differences. The independent variable, what we're trying to see what is changing, the dependent variable, the one we want to measure, and the control variable, we want to keep everything constant. And in here, the first one is the width of the rubber band is different, right? So that's something we want to test. So something we want to change. That is our independent variable. In the middle one, the dependent variable, the distance and the weight travel. So in here, we want to keep that something that we can measure. So we measure what is the distance it can travel. And the control variable is the amount that the rubber bands are stretched. So the stretching itself should be controlled. In here, we take a look at the procedure. So in here, in our first step, we'll set up this setting. So in here, you need to pause the video and draw it in. Please use a ruler because I have taught you how to do that in the first term already. Please do a proper drawing with the labels and the lines. In here, I will just show you the procedure first, and I know that some of you want to copy it down, and please pause the video and copy down this procedure. So in number 2, you pull the weight down to a certain point and let go of it. And then number 3, you record the distance the weight travels. And number 4, repeat the step 2 and 3 times, take the average. And repeat the 2 to 4 steps using different rubber bands. So the narrower one, if you started with that, you use a wider one in the second trial. And in here, just a caution, what you need to be careful of. You need to wear safety goggles and do not pull the rubber band too hard or else it breaks, right? It's common sense. And in here, in the results, and as I told you, we don't have that for you, so that's why you referring to the back to the video, those would be your results for it. And unfortunately, from that, we need to come to the conclusion and a discussion. Which rubber band stores the most potential energy is the widest one. And number 2, what the relationship? The wider the rubber band, the more potential energy it stores. Okay? And in here, in the checkpoints 5.2, let's do this one now. When the boy walks upstairs, what energy is being converted into what? So he starts to walk. So he's starting from the walking is the kinetic energy, and the higher he goes, the more potential energy is being stored. So if you're not sure, think of it, if he walked all the way up to the first floor and then he slipped, and then all the potential energy would convert into kinetic energy, and he fell downstairs and he get hurt. So that's how you want to make sure you understand which energy is converted into what energy. And in B, In here, the electric fan is switched on. So from the battery itself, you should know that by now is the chemical energy. It's being converted into the fan. Something is moving. So it's obviously it is kinetic energy. Okay? So that comes to the end of the first part of 5.2. And please make sure you copy down the steps and the procedures and drawings in this video. Okay?